Hi, my name is Lisbeth Ramos, and today we're going to be going over the Pauli Exclusion principle. So first, let's talk about what the Pauli Exclusion principle is. So what this means is that no two elements or no two atoms can have the same set of quantum numbers. So this means that no two arrows can be in the same direction, in the same orbital. And we're kind of going to look at exceptions or look at what's going on over here that defeats the Pauli exclusion principle. So that means if I have an atom that has the quantum numbers n equals 2, L equals 1, M sub L equals positive 1, and M sub S equals positive 1/2. If I have an atom that has these four quantum numbers, that is the only atom on the periodic table that's going to have these four quantum numbers. They can be similar, so I can have n equals 2, L equals 1, M sub L equals positive 1, and M sub S equals negative 1/2. That's fine, but all four cannot equal the same thing, because then you're looking at the same, and if they are the same, you're looking at the same atoms. Different atoms will always have different quantum numbers. So let's go ahead and look at these. Let's see what's going on over here and why some of these are incorrect. So one thing is that in each orbital, in the s orbitals, you can only fit 2 electrons. So in s, you can only fit 2 electrons. In p, you can only fit 6 electrons. In d, you can only fit 10 electrons. And in f, you can fit 14 electrons. So this is kind of important to know. So 2, 6, 10, and 14. Alright, so over here we have our s orbital and it has 2, so that's fine. And they're facing in opposite directions. So that means that their m sub s values are different. Here my n value is 1, my n value is 1, my L is 0, my m sub L is 0. This electron right here is going to have a positive 1/2 and this one's going to have a negative 1/2. So then they have different quantum numbers. Same thing over here. Now when we get to the p orbital, we see that we have 4 electrons. That's fine, even though it's not 6, because the maximum is 6, but it can have a varying number of electrons. Notice, however, that in this orbital right here, I have 2 up-facing electrons. That's not possible because this and these 2 electrons will have the same quantum numbers. Their quantum numbers are going to be n equals 2, L equals 1, M sub S equals positive 1/2, and M sub L equals negative 1. So if they have the same quantum numbers, that doesn't follow the Pauli exclusion principle. So this one must be facing down in order for the Pauli exclusion principle to be able to work. So let's look at the second example. Here we have 2 electrons, one's up, one's down. That's beautiful. So is this one. Here we have, they followed Aufbau's principle, which is up, 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 and then they filled in the bottom one, and all of them have different facing electrons. So this one's fine, right? This is a perfect example of something following the Pauli exclusion principle. Over here, my 1s, you can already tell that something's wrong because they're both facing up. This one must be facing down for the Pauli exclusion principle to be able to work. And let me just verify to make sure everything else is fine. So this is up and down. And then they followed the building up principle. So that one's fine. Here, we have all sorts of things going wrong here. First of all, what is this? There's 3. You can only fit 2. No, wrong, right? And then they're all facing up, like, no. Ideally, this would have to look like 2s, 1 up, 1 down. And that extra electron should actually be over here, right? Notice that before I put this guy over here, they didn't follow the building up principle because they were supposed to fill the shell with upward facing electrons first and then go back and fill the downward facing electrons. So this was just all sorts of no. All right. So to recap, we have to make sure that in each orbital, so in S we can only have 2, and P we can have 6, and D we can have 10, and in F we can have 14. And we have to make sure that each one in each respective line, there's 1 upward facing electron and 1 downward facing electron. That represents the spin. If it's facing up, it's positive 1/2. If it's facing down, it's negative 1/2. And that really makes sure that we don't have the same 4 quantum numbers. Also make sure that they're following the Aufbau's principle, which means they fill all the possible subshells with a upward facing electron first, and then they go back and fill in a downward facing electron. So yeah, that's how you use Pauli's exclusion principle to figure out if something is correct or not.